So basically, as far as the second part is considered, the interval given of x is 1 to infinity. So in this sub part only, we'll basically divide this sub part into two parts, where firstly we'll find out the value of tan inverse of tan 2 theta, which is basically u, and in the next part of this sub part we'll find out the value of sine inverse of sine 2 theta. So this is v, and basically this thing will be dealt with first and this thing will be dealt with later on. So this thing we can forget it right now. First we'll move on with this. So when x is in between 1 to infinity, basically tan theta varies from 1 to infinity. Basically theta varies between pi by 4 to pi by 2, and basically 2 theta ranges from pi by 2 to pi. So here basically we can see that this is not the interval of minus pi by 2 to pi by 2. So we have to change it into minus pi by 2 to pi by 2, but here the function change should not occur and the magnitude change should not occur, as discussed in the previous video. So for no function change, basically pi by 2 should not be used. This should be taken in mind, that pi by 2 is not used in the conversion of this to a subset of minus pi by 2 to pi by 2. So pi by 2 cannot be used, now pi. Now how can pi be used? The first thing which comes to your mind, to convert it to a subset of it, we can subtract pi from all the three parts. First we'll subtract and then we'll find out whether it caused a change in magnitude or not. So when we subtract a pi, it changes to minus pi by 2. This changes to 2 theta minus pi. This changes to 0. So basically this thing ranged from minus pi by 2 to 0, which is definitely a subset of minus pi by 2 to pi by 2. But we have to see whether it caused a change in the magnitude of tan 2 theta. Tan 2 theta was initially positive. When we substitute 2 theta minus pi in place of 2 theta, we find out tan 2 theta minus pi. This can be written as tan of minus of pi minus 2 theta. Minus sign was taken out common. Since tan of minus x is basically minus tan x, this can be written as minus of tan of pi minus 2 theta. Now if we consider the quadrant, this is pi. So this is sine ka range and this is tan ka. So pi minus 2 theta, this is basically tan is negative over here. So this will come out to be minus and minus of tan 2 theta, which will be plus tan 2 theta. So we see that it did not cause a change in the magnitude. So definitely this procedure was correct. Now, so since this procedure was correct, so directly this can be written as 2 theta minus pi. In the second case, this thing tan inverse of tan 2 theta evaluated to 2 theta minus pi. Now this second part, in which we'll so the second part of the question is to find out the value of sine inverse of sine 2 theta in this range of x, in this interval of x. Since sine inverse of sine 2 theta, which is equal to v, this has to be found out. So in this case we have basically seen that 2 theta is originally ranging from pi by 2 to pi, so we'll directly copy it out. So 2 theta is ranging from pi by 2 to pi. Now this thing has to be changed into a subset of minus pi by 2 to pi by 2. So, and pi by 2 cannot be used in the modification. Pi by 2 cannot be used, function change not allowed. Magnitude should also not change. So if this thing is only applied, if 2 theta minus pi is only applied, we can see that if pi is subtracted directly, so this will obviously change to this interval. But we should also check that whether it caused a change in magnitude of sine 2 theta or not. So we'll substitute 2 theta minus pi in place of sine 2 theta. This will give us 2 theta minus pi. This will give us minus of sine of pi minus 2 theta. Obviously minus sign was taken out, sine of minus x is minus sine x. So this is basically minus of, and as we can see, this is pi, this is sine. So pi minus 2 theta, pi minus something, will give us the quadrant in which sine is positive. So basically this thing resulted out to be positive, and here's a negative sign. So basically it is minus of sine of 2 theta. This did cause a change in the magnitude. So this process is not applicable for sine 2 theta. This was applicable for tan 2 theta, but it is not applicable for sine 2 theta. So something else must be thought of. So now we'll basically multiply everything by minus 1. So this thing will change to minus pi by 2. Inequality sign change, minus 2 theta minus pi. Now what if we add pi? I guess adding a pi would be quite convincing over here, since this will change to 0, this will change to pi by 2, and 0 to pi by 2 is a subset of minus pi by 2 to pi by 2. So if we add a pi over here, this thing changes to 0, this thing changes to pi minus 2 theta, and this thing changes to pi by 2. This can also be written as 0 pi minus 2 theta pi by 2. So we also have to check whether this caused a change in magnitude or not. So basically we will substitute pi minus 2 theta in place of 2 theta. We see that sine of pi minus 2 theta, this is basically in the sine quadrant only, so this will be positive sine 2 theta. It did not cause a change in magnitude, so this is allowed. So basically in the second subpart, sine inverse of sine 2 theta evaluated to pi minus 2 theta. So basically u evaluated to u, which was tan inverse of tan 2 theta, it evaluated to 2 theta minus pi, which is 2 tan inverse of x minus pi, and in this case it is pi minus 2 tan inverse of x, which is equal to v. Okay, because we had used the substitution, x is equal to tan theta due to the following reason. And now we can easily find out du by dx over here and dv by dx over here. Since dv by dx can be found out, I guess this was covered in the video, that this is pi minus 2 theta, this is pi minus 2 tan inverse of x. dv by dx can be found out, and du by dx divided by dv by dx will give us du by dv.